In Excel Module 3, you're introduced to a variety of functions and formulas where you can really start to see the power behind a program like Excel, where it can build in all of these calculations automatically into a project so that all you have to do on an ongoing basis is to enter data and let Excel do all the hard work for you. But we're going to be setting up some of the formulas and functions in a spreadsheet for this project. And so let me work along with you step by step as we go through the instructions of this project. So starting out, we can read the background of the project, that this is for Keith Herman, who works for Snack and Pack. And Snack and Pack is a startup that sends box sets of packaged snacks to its subscribers on a weekly basis. He keeps track of the company's sales and inventory, as well as relevant product information. And so this spreadsheet is going to be one that needs to work on a weekly basis. It's going to be updated and distributed weekly. And so it just needs to be easy to use. It needs to be clearly identified what data goes where, and all the formulas need to be tested and working. So we're going to start out at the very beginning of the project, saving the document under a different name. So I'll go to File, Save As, choose a location, and then the instructions tell me to change the name by deleting the 1 and adding a 2 at the end. And so now I have my saved workbook and the name is reflected at the top. And then the first step is to go to the orders worksheet. You can see there's 3 worksheets total in this workbook right now. So we're going to go to the orders worksheet. And in cell A2, we're going to insert the now function to record the current date and time. Now, if you already know what function that you want to start typing in a cell, then you can simply type it in. And we're going to do that with some of the functions today, but we're also going to use this F of X button up here for other functions. But the now function is simple, so we can simply type it by typing equal, and then I'm going to start typing in, and you can see the drop-down list that comes up of all the functions starting with N, and as I type, it'll narrow down this list for me. So I type N, O, and then there's the function I want, so I could move down to it, or I could simply finish typing N-O-W. But then every function requires parentheses after the name. So I'm going to start with my parentheses, and it tells me here that there's nothing required inside the parentheses. Otherwise it would describe in the middle what's required. So I just need empty parentheses and press enter, and it adds the current date and time that that you're working on the spreadsheet. Step 2 of the instructions tells us to look at the transaction growth section so we can see how many box sets were sold each month. And you can see the different names of the snack packs that he sells. There's Fitbits, Great Grains, Munchie Madness, and Sweet Stuff. And this transaction growth section shows how much was sold at each month of the year. And then at the end, it looks like there's a column that's supposed to show the most ordered any month and the least ordered any month. And then at the far right of the transaction growth section, you have a special kind of a chart that you'll learn about in chapter 4 called a spark line. A spark line chart is pretty cool because it fits in a single cell, and it's charting the growth pattern for the month. So you can see how January, February are really low, so those are the low ends of the month, of the line, and then the high end is somewhere around August. That's the highest number, so that's reflected by that red dot in the spark line. So those are already there. We're actually not going to do anything with them. I just wanted to show you what they were for. But back to the instructions. In step 2, it says that Keith entered a formula in range 06 through 010, that's this most ordered column, to calculate the highest amount of each set sold over the course of the year. But he notices that all the numbers are 1408, and that obviously is not correct. Those should be different numbers for each of these snack packs. And so we need to edit the formula. First, let's look at what the formula is. in cell O6, we can look in the formula bar and we see that it's showing the max function using the range B6 through M6, B6 through M6. So that looks like it's correct for Fitbits. Let's look at the formula in the next row down for Great Grains. It's showing equal max B6 through M6. So it's getting the max from the row above it, from row 6. And so that's not right. And that's obviously what's happened in all of these other rows as well. So what happened is that when the formula was entered in cell O6, the cell references were made absolute by putting the dollar signs in front of the columns and the row numbers. When they're absolute like that and you copy this formula down a column, it keeps those cell references from changing. And that isn't what needed to happen in this case. They needed to be updated based on the rows where we were copying the formula. So what we need to do is edit the formula to take out those dollar signs. So I'm going to do that in the formula bar. It's just a little easier to see. And I'm just going to edit and take out all 4 of those dollar signs and then press enter. And then I can copy this formula from cell O6 down through the rest of the column, and this time it should work. But now instead of copy and paste like we saw in Module 2, we're going to use this feature called autofill. That's when you use the lower right corner of a cell to drag down across other cells that you want to copy that the cell contents into. So I'm going to do that here. I'm going to drag this lower right corner down across the column, and it updates the formula in every cell, but it also by default will change the formatting. But we have the autofill options button that automatically appears as soon as we finish with the autofill, and if we click that button, we have access to some options where we can tell it whether we wanted to include the formatting or fill it without the formatting. And in this case, we want to fill without formatting so it can keep the original formatting of the rows. So fill without formatting, and it still updated the formula, but it kept the format of the banded rows. So now if we look at each formula in column O, it should be correct. If I look at O7, it's getting the max of B7 through M7. And O8, it's getting the max of B8 through M8, and so forth. Okay, so now to step 3. It says in cell P6, create a formula using the min function to find the lowest number of Fitbits box set ordered through the year. So that is the min function, will give you the least number ordered. Min is one of those functions that's available through AutoSum. So I can click up here and choose min. By default, it's going to choose every cell containing numbers immediately to the left of this cell where I'm entering the formula. But I don't want it to include cells N6 and O6. I just want it to go from January through December. So what I'll need to do is before I press enter, just come back and select those cells for Fitbits from January through December. And then release my mouse button and press enter, and it gets the correct formula entered into cell P6. So I've got that formula entered in the first row of this set, and so now I can use the autofill handle to fill the rest of the column, use the autofill options to tell it to fill without formatting. And that completes step 3. Step 4, step 4 says to go to cell B12 and create a nested formula using the average and round functions to find the average number of boxed sets sold in January and then round that answer to 0 digits. So a nested formula is when you have one function inside another function. So we're going to start by getting the average. So I can type it in, or I can use the AutoSum button to get the average. In this case, I'm going to type it. I'm just going to start typing average, and as soon as it comes up there, I can press tab to select average, and then it's waiting for me to tell it what cells to average, and I'm going to select the cells B6 through B9. I want to be sure and not include the total in B10. So B6 through B9. And I'm going to then type a closing parentheses and press enter. So that has given me the average of January, but it is not rounding it to 0 digits. So what we want to do in that case is nest the average function inside a round function. So I'm going to come up to the formula bar so I can edit this a little better. And before the word average, I'm going to type the word round and then a parentheses. So I'm telling it I want to round the average, but then I need to come to the end of the average function and type a comma. And you can see it's kind of prompting me down below what I need to type. So after the comma, I need to tell it how many digits I want it to round to. And I want it to round to 0 digits, and then my parentheses. So this is the nested function we want. We're rounding the average of B6 through B9 to 0 decimal places, and then press enter. So now we have 169 rounded to 0 decimal places. And when you use the round function like that, that's gives you a more precise answer than just formatting it to have 0 decimal places. When you format it to have 0 decimal places, it keeps the fractional part of the answer as part of the cell, but when you actually round it, it gets rid of the fractional part altogether. In case we were to use this number in another calculation, it would just be the whole number without the fractional part. And so we have the correct cell, or the correct formula in cell B12. We can simply use autofill to fill it to the rest of the row through N12. And we can keep the formatting since it's all going to be that shaded color in row 12. All right, so now step 5. The data section called Inventory Tracker shows how many of each box set component has been ordered by the company each month. So it shows the different components that make up these snack packs and how many are ordered throughout the month with some statistics about the orders. But the first thing we want to do is fill in the rest of the month names. It started January, February, and March, but we need to get the rest of the month names entered. And this is when we can use the autofill feature of Excel, where it can fill in recognizable patterns, and month names and month abbreviations are one of those patterns it recognizes. So I simply select what's already been filled in, use the autofill handle to drag across through column M, and it automatically fills in the rest of the month abbreviations. Step 6 tells us to go to cell O16 and create a formula using the max function to find the max amount that was ordered from January through December. So again, I can use the AutoSum function to enter max. It defaults to all the cells containing numbers to the left, but again, we don't want to include the total. We just want to go January through December. So I can highlight again those cells and then press enter to finish the max function. And then I want to copy that formula down through the rest of the column using the autofill handle and use the option to fill without formatting. Step 7 tells us to switch to the product lookup worksheet. So I'm going to move to that worksheet. And here we have some information about the box sets and the components that come in each set, and some shipping information, and we're going to use some lookup functions on this worksheet to look up some data and do some formatting as well. So the first thing it tells us in step 7 is to come over here and correct this entry in cell B10. We typed out the words 100 instead of adding the number 100, and that's causing an error down in B14. We can see the error has the number sign value, and if I want to find out more about that error, I can simply click on the cell and then click on the error box that appears just to the left of it, and it gives me help on this error, so I'm going to do that. And it brings up Excel's help, and it's going to tell me how to correct a value error, and it tells me a little more about what that is. And let me just read a little bit. It says it's its way of saying there's something wrong with the way your formula is typed, or there's something wrong with the cells you are referencing. So if we look back at this cell, the formula contained in it is equal B8 plus B9 plus B10. So we're supposed to be adding cell B8, B9, and B10. But because B10 does not contain a number, instead it contains text, it gives that value error and says it can't add those 3 cells. So we're going to correct that by typing the number 100 in cell B10. So let me just type over it. I typed 100 and press enter. And as soon as I do that, that value error goes away because now it can correctly add those 3 cells. All right, step 8 tells us that the data section called boxed set, which is, or box set information, starting in A13 is incomplete, and we're going to fill in some of this. In cell B16 for Munchie Madness, we're going to create a formula using the sum function to find the total calories in the Munchie Madness box set by totaling the calories from baked goods, bars clusters, granola, and popcorn. So we simply need to add an equal sign and type sum and parentheses. And now here we have to actually tell it what cells we want to add up, since it's not an adjacent range of cells. And we can do that by typing or by clicking, but we'll have to put a comma in between each cell reference. So I'm going to start by clicking on B5, then I type a comma, and then B6, type a comma, B9, type a comma, and then B11. And so we're adding these 4 cells, and you may wonder why we're adding just the calories of those 4 cells. Well, if you look down in rows 19 through 23, it tells you the box set configurations. And since we're working with Munchie Madness, we can see that Munchie Madness is made up of baked goods, bars clusters, granola, and popcorn. So those are the only calories we're wanting to add here: baked goods, bars clusters, granola, and popcorn. So we get those 4 cells typed out into our sum function. We press the closing parentheses and enter, and it's calculated the calories for us. Then in cell C14, we want to create a formula that'll basically count the number of components that make up each of these box sets of snacks. And so there is a built-in count function in Excel, and that's what we'll use here. I'm going to just type this in as well using count. Now notice there's a count and a count A and a few other types of counts, but count and count A are the 2 that you'll use the most. Count will count the number of cells in a range that contain numbers. But if you notice our box set configurations, they don't contain numbers, they're just text. So count A will count the number of cells in a range that are not empty, no matter what is contained in those cells. And that's what we want to do in this case, is count A. So I'm going to do count A and then a parentheses, and then we want to, since we're working on the Fitbits boxed set in row 14, then we're going to select the cells that might contain components for Fitbits. I'm going to select all of this B through F20 so that it'll count all the cells in that range that are not empty. And the reason I want to go all the way from B to F, even though I can visually see that these are empty, I want to be able to enter a formula here that I can copy down the rest of the column. And so I want to refer to all the possible columns that could contain a component name. So I finished my count A function using the references B20 through F20 and then parentheses. And I pressed enter, and it correctly counted 3 components in Fitbits. Then I can go back to C14 and use autofill to drag down to copy that formula without formatting, fill without formatting. And so it's correctly counting the number of components in each box set. So Great Grains has only 2 components, Munchie Madness has 4 components, and Sweet Stuff has 5 components. Number 10 says that the data section called Product Information Lookup over here in column H uses a mix of user input cells, output cells, and calculated cells to display various information of a single boxed set. And so we're going to format these cells to show whether it's input cells where the user is supposed to type in data, or it's an output cell where it's just looking up information and showing you the result, or if it's a calculation. And those are built-in styles that we can take advantage of in Excel to give us a consistent look. So we'll start by going to cell I5 and apply the input style. On our home ribbon, I'll go to the styles and use input for I5. For I6 through I8, I want to use the output style right there. And then I9, I want to apply the calculation style. And then I10 has already been formatted for us in the output style. Then step 11 in our instructions, we're going to use a lookup function called VLOOKUP that will allow us to use this information over in columns A through F and look up information about a single boxed set. So we've got a sample box set name typed in I5. We've got Sweet Stuff typed out. But the idea of this kind of a lookup area is that we'll be able to type different names of box sets here, and all the information below it will change based on what it looks up and finds related to that box set in the rest of in cells or in columns A through F in this spreadsheet. So in cell I6, this labeled calories, we want to create a formula that will look up the number of calories that belong to the named box set in I5. So for this function, we're actually going to use the f of x button. That's the insert function command that brings up a dialog box and walks you through more step-by-step of entering the arguments needed for particular functions. And for the VLOOKUP function, I really like this because it's slightly more complicated arguments that you use for this function. So we'll start with f of x, brings up the dialog box. We could actually search for a function if we weren't sure what we were looking for, or we could select the category that it's in, and I know it's a lookup function. And then I would scroll down and find VLOOKUP. And it will give me information about that function. If you're not sure that's the one you want to use, you can read its description. But then once we choose it, we click OK. And then the next step shows us all of the required arguments in bold here for this function, and then optional arguments may be listed that are not in bold. And as we click in the box next to each argument, it does tell us at the bottom what that argument represents. So the first one, lookup value, is the value to be found in the first column of a lookup table. In this case, let me move this out of the way just a little bit. There we go. We are looking up whatever is in cell I5. That's going to be what we're looking up in the first column of the lookup table. So our lookup value is simply cell I5. So I can just click on I5 and it puts I5 there. The table array is a table of text numbers or logical values in which data is retrieved. So that's where the data is that we're looking up. And since we're looking up calories, we're going to use this table that's in A14 through D17. Oops, let me try that again. A14 through D17, and it puts the range reference in if I just come out and select it. But that's where our table of calories are found. And then the third argument is our column index number. And if you look at our table of data, this is our first column where we have the box set names. Our second column is where the calories are found. And that's what we're looking for in cell I6 is the calories. So my column index number is going to be 2 to show that I want the second column of data from the table. And then the last argument is a range lookup argument, and we're almost always going to type the word false for the range lookup argument because that means we want an exact match. We're not looking for an approximate match. Range lookup means do we want an approximate match? That would be true. False means we want an exact match. So we have our arguments filled in. We click OK, and that VLOOKUP formula has been entered in I6, and it's gone out and retrieved the fact that there's 363 calories in the sweet stuff box set configuration. If I were to click on I5 and type another box set name like Fitbits, then watch what happens to I6 when I press enter. I press enter, and so now the calories is 267 because that's what is associated with Fitbits in our lookup table. But let me change that back to sweet stuff, and we'll continue. So now we're on step 12 of the project instructions. In cell I9, we're going to create a formula without using a function that first adds the selected set's net weight in I8 to the packing weight E5, and then divides by 16 to show the shipping weight in pounds. So I'm going to type it pretty much like it's read there, but I'll tell you in advance it's not going to be correct until we fix it. But I'm going to say I8 plus E5 divided by 16. And let's look up in the formula bar at that formula. So I've done pretty much what it said. I added I8 to E5 and then divided by 16. But what it's wanting is it wants the addition to happen first. It wants me to add I8 and E5 and get that result and then divide by 16. And so when you need to change the natural order of operations, you need to use parentheses. So we're going to put parentheses around our addition so that it'll complete that before dividing by 16. And then press enter. And then in cell I9, we have the number of pounds for shipping. Step 13 of our project says that the delivery service used by the company charges a higher rate for packages weighing over 3 pounds. So in cell I10, we want to add a formula that will show the word yes if the shipping weight is over 3 pounds, but it'll show no if it's not over 3 pounds. So that in that case, we're going to use an if function. An if function is perfect when you have an either or situation. That if this condition is true, you want one option shown in the cell, but if this condition is false, you want a separate option in the cell. And in this case, we want either yes or no. So we're going to use the if function. Start by clicking f of x. I'm going to type the word if and click go. And it does bring up if as the first option. I'll click OK. And I have 3 arguments I need to fill in. The first is a logical test that's going to be evaluated as either true or false. Our project instructions tells us that we're checking to see if cell I9 is greater than 3. So I'll type I9 greater than 3. If that is true, then I want the word yes, so I can type the word yes. And if it's false, I want the word no. Now notice I did not type these double quotes around the word yes or no, but Excel automatically will insert them when I'm using this f of x dialog box. If you were to type the function out without the dialog box, you would have to type the quotes yourself. But this is my function arguments that I want, so I'm going to click OK, and it correctly put the word yes because my current shipping weight is over 3 pounds. Now let's back up a minute and look at the cells that already had formulas entered in them. In cell I7, we can see they used a VLOOKUP function with a column number of 3 to get the number of components returned from the third column of our lookup table. And then in cell I8, we can look in the formula bar to see the VLOOKUP function that uses a column number of 4 to give us the net weight from that lookup table. So those formulas were already entered. We just entered the one to look up the calories. And then we entered the shipping weight calculation that takes the net weight of all the components and then adds it to cell E5, which is the packing weight, the weight of materials added for packing, to get the total shipping weight. And we divide by 16, so it's returned to us in pounds. And then we added the if function to determine whether the shipping weight was over 3 pounds or not. So now the last thing we're going to do is use a special built-in feature of Excel called GoalSeek to determine how much packing weight we would need to keep the shipping weight under 3 pounds, because apparently we could get a discount if we can keep the shipping weight under 3 pounds of these box sets. And so we could do some trial and error. We could play around with this packing weight and say, well, what if it's just 20 ounces? What does that do to the shipping weight? Well, in this case, it changed it to almost under 3, but not quite. Well, what if I made it go down to 15 ounces, the packing material? Well, that's quite a bit under 3. Maybe we could do better. So we could do some trial and error, but the built-in feature of GoalSeek in Excel will do this much more quickly for us. So we're going to do that by starting at the data ribbon, going to what if analysis over in the forecast area, choose GoalSeek. It brings up a dialog box. First, we need to tell it which cell we want to set to a specific value. And in this case, we want to set cell I9 to a value just under 3. So 2.9 is what the project instructions tells us. So we're setting cell I9 to 2.9 by changing cell E5, which is the shipping or the packing weight, and that was one of the cells used in the formula for cell I9. So as soon as I click OK, it will go through all the possible combinations and come up with the ideal number for cell E5 that would make cell I9 the value we want it to be. So let me click OK, and we can see it try a few possibilities, and it comes up with 17.4. We click OK to keep that recommended number, and that gives us a shipping weight that is under 3. So that is this project. It should look like the final figures in the instructions, and you have learned quite a bit about functions in this project.